Namaste, welcome to my channel Qubit Educational Services. In this video we will be talking about the IISER Aptitude Test 2022 Mathematics section. We will be discussing the overall paper pattern and the difficulty level as well as the detailed solutions of all the questions under Mathematics section. So first we will take a brief overview of what type of questions were asked, on what topics were they based, and the difficulty level. So these are the questions from 31 to 45. This is the order in which I got the questions. It need not be in the same order. They need not be in the same order, but definitely the questions were identical. Alright. So first question 31 in my PDF was on vectors, relations and conics all put together. And the difficulty level was not too much, so this is an easy question. Okay, so the question was basically to identify what type of conic section the given set of points in the 2D xy plane represents. Okay, question 32 was also a straightforward geometric progression problem. Question number 33, which I found was a bit challenging, so I have put that in the difficult in the difficult section. It was on limits. We had a product of f and g and its limit existing as x tends to 0, and then we had to decide on the behavior of individual limits of individual functions f and g. Okay, question 34 was on linear algebra, which was basically based on properties of determinants. Okay, the determinant of the product of two matrices is the product of the determinant of the individual matrix. That was the only thing. Then in question number 35 we were given the focus directrix property and we had to decide as per the eccentricity what it might be. So I found this to be the easiest of all, the conic section. Okay, then question 36 had a cubic polynomial given to you and you have to decide the range of the constant term, that is alpha they call it, and we had to use both the applications of derivatives as well as some things from polynomials to come to the answer. So according to me, well, it was not very difficult. It was a moderate question. If you knew the basics of polynomial functions, the curves, then you could have easily tackled it. Okay, question 37, I didn't find anything challenging there. Straightforward binomial theorem question. Question 38 was also not too difficult. It was a simple discrete probability question. They were not even asking you about probability distributions or random variables. Okay, then there was a question on complex numbers which I found a bit more challenging. Well, that need not be obviously the case with you, but well, I found it a bit difficult. Well, I have actually solved it in two ways: by elimination of the other three options as well as by proving why this specific option is right. Okay, so that was on complex numbers. Then there was a question on inequalities and modulus function and also complement of a set. So we will also solve it. It was also a very simple question. In fact, all of them from 40 to 45, I didn't find them too challenging. So the next question was on the number of skew symmetric 4x4 matrices from the given entries. So it could also be solved by using multiplication principle of counting. Then we had a conic section problem, a circle intersecting parabola. Well, okay, that was I think the question, conics, but okay, that was also an easy question. Then we had a question on trigonometry and how the graph of the trigonometric function changes if you, let's say you have sin x, and if I include k here, then what happens to the interval in which it increases, what happens to the interval in which it decreases, and so on. Okay, well, as we change k, that was a question. Then there was another question on area integration. This was, I think, a very simple question on integration. I didn't expect that. That was also an easy question. You could use the symmetry of the figure to actually calculate the total area by multiplying the area in the first quadrant by 4. And at last we had a 3D geometry problem where there was a point given and the direction ratios of the normal were given and we had to find the equation of the plane. Okay, so overall, if you judge it from my view, I think though there were only 2 or at the most 3 very extremely difficult questions, you could say, and the rest of the paper was very easy. I'm not saying it was not conceptual. It was conceptual, especially the conic section question that I talked about, focus directrix property. If you don't know what it is, then no matter how many other things you know about parabola, ellipse, hyperbola and circle, you will never be able to solve the question, because it was a very basic level question. Okay, so that's my judgment on the mathematics section. Now we will solve all questions in that particular sequence one by one. Alright, so let us now start solving the questions. We will start with question number 31. Let S be the set of all points in the xy plane and let O be the origin. If R, which is a subset of the Cartesian product S cross S, is the relation of, it is a relation consisting of ordered pairs of points P, Q, such that the magnitude of the vector OP bar is 2 times the magnitude of the vector OQ bar, and suppose P is any point other than the origin, then the set of all points Q related to P forms O, or an circle, hyperbola, parabola, or an ellipse with distinct foci. Okay, so this is a very simple problem. What I have done is, they have said P can be any point other than origin. So I have decided to take P to be the point 0, 1, a point on the y-axis. Okay. Now see, because we know that in this examination there is only one option that is going to be right among the 4 given. Whichever other choice that we make of the point P, we should be able to get the correct answer. Okay, so suppose P is the point 0, 1, and suppose the point Q has coordinates x, y. Alright, now when they say that magnitude of vector OP bar is equal to 2 times the magnitude of the vector OQ bar, they're basically telling us the distances. Okay, so mod OP bar is the distance OP, which is 1. Okay, and mod of OQ bar is basically the magnitude of the vector xi cap plus yj cap. Okay, so that will be root of x squared plus y squared. That's a very simple property, right? Okay, now if you square and take this 2 to the other side, which becomes 4, you get x squared plus y squared equal to 1 upon 4, which is essentially a circle centered at origin. Well, now those details are minor details, we don't need them anymore, because we have got our answer that the set of all points Q related to P is basically a circle. Okay, so this was a fairly simple question, and as I've already told you, they have actually combined ideas from 3 different things. Vectors, you need to know how to find the magnitude; relations, you need to know what a relation is; and then of course conics for the identification of the final equation. Okay, so that was 31. Let's go to 32. A coffee company started its business with 4 branches at the beginning of the year 2014. If the number of branches doubles at the end of every year, then in which year will the company have at least 2022 branches for the first time? 2024, 2022, 2021 or 2023? These were the options. This is also a simple question, but you need to pay attention to the way you perform the calculations. Okay, so what I have said is, okay, because the problem tells us that the company is doubling at the end of every year, we can say that suppose the company had 4 branches at the end of the year 2013, which is as good as the beginning of the year 2014. Yes. Now in the year 2014, although the company began its operation in that particular year, at the end it is going to double. So when 2014 ended, the company basically had twice as many branches as it had in that particular year initially. So that makes it 8. Correct? Now this will repeat, because they have said it repeats the number of branches at the end of every year, which means at the end of 2015 the number of branches will get doubled, so it will be 2 times 8 or 16. Okay, the other thing that you need to observe here is that because this number 4 is also a power of 2, an integral power of 2, I've utilized that. So at the end of 2014 it is 8, so I've written it as 2 raised to 3, then 2 raised to 4, then 2 raised to 5, then 2 raised to 6, and so on. right? So I've gone till 2017 just to recognize the pattern. So at the end of the year 2017, the number of branches is 2 raised to 6, which is 64. Okay. Now let's try to figure out or find out rather, in which two perfect powers of 2 does the number 2022 lie? Okay, the number 2022 lie, and it's not very difficult to find out. The number 2022 lies between the powers of 2, which are 10 and 11, because 2 raised to 10 is 1024. Well, I hope you knew that already. So 2 raised to 11 is 2048. So it's in between 2 raised to 10 and 2 raised to 11. Okay, so basically this is what we now want. Okay, because this particular number 11 will take us one step closer to our answer. Okay, so the other thing that I want all of you to observe is that, okay, this power here is basically 1 less than the last digit, or you can say the last 2 digits. So it's 17, so it's 1 less than, so that's 6, 16, so 5, 15, so 4, and 14 is 3. Okay, so as this year increases, as you go on taking the next years, this index of 2 will increase by 1. Okay, now we want 2 raised to 11. Okay, so what I've done is I've added 5 to this, which would also mean that in the year 2017 we should also add 5. So that basically tells us that at the end of the year 2022, okay, how many branches will the company have? 2048 branches. See, it is at the end of 2022 that the company will have 2048 branches. Now let's return to the question. It is saying, in which year will the company have at least 2022 branches for the first time? Okay, so if it is at the end of 2022, definitely 2022 is not what the year that we should mark. It's the next year, right? So the correct answer is 2023 and not 2022. Okay, they're saying at the end. At the end means 2022 has ended and 2023 is about to start. It's that time where the number of branches doubles. Okay, so it's not the one to the left of that, it's to the right. Okay, so it's 2023. Yeah, whichever option knows that. That's 32. Question 33. Let f and g be functions from R to R. If the limit of f into g as x tends to 0 exists, then which of the following statements is true? The limit of f as x tends to 0 need not exist. B. The limit of f into g as x tends to 0 is f of 0 into g of 0. C. Both the limits exist of f and g as x tends to 0, and limit as x tends to 0 of f is f of 0, or limit of g as x tends to 0 is g of c. Okay, so we have to decide which one of them is the right one. Now to solve this question, well, I already told you that this is, according to me, a bit difficult question. I have used elimination. So what I have used is, I have first used our very well known limit, which is limit as x tends to 0, sine of x upon x is 1. Okay, and now I have written it as 1 over x into sine x equal to 1. Okay, now that allows me to take f of x as 1 upon x and take g of x as sine x. Okay, now if I do that, we clearly get the satisfaction of this thing. The limit exists and it is equal to 1. Well, the value is not important, we just know that the limit exists. Okay, now because of my choice of f of x, which is 1 upon x, clearly limit of 1 over x as x tends to 0 doesn't exist, so option C is gone. Okay, which says both exist. Now both means it is like the logical connective and. Even if one of them is not true, it won't work. So C is gone. And also f of 0 doesn't exist. Okay, f of 0 doesn't exist because the function is also not defined. So it possesses an irremovable discontinuity but at the same time the function itself is not defined there. So clearly f of 0, if it is not defined, then there is no question of the right side's existence, right? So option B is also gone. So it's whether the limit of f as x tends to 0 need not exist, or it is the D thing. Okay, this or this should be 0. Okay, now to decide whether it is A or D, I've made use of the fractional part function and the greatest integer function. Here is what I have done. Okay, so I'm calling f of x as the greatest integer function of x plus 1. So it is box x plus 1, so I'll call box as greatest integer. So f of x is box x plus 1. Now we know that any function of the kind x plus any integers box, okay, it is always discontinuous and it possesses a jump discontinuity at every integer, right? So clearly box x plus 1 will also be discontinuous. Okay, it will be discontinuous with a jump discontinuity, that's important, with a jump discontinuity at every integer including 0. So clearly the limit of the function box x plus 1 as x tends to 0 doesn't exist. Okay. Now what about the fractional part function? Well, we all know that even this function is discontinuous with a jump discontinuity, that is a removable discontinuity at every integer box x, fractional part of x. So that also doesn't exist. The limit doesn't exist. Okay. So well, because both the limits don't exist, it should be clear to you now that if these things don't exist at all, it is meaningless to say that they are equal to f of 0 and g of 0 respectively. Okay, it's meaningless to say that they are equal to f of 0 and g of 0 respectively, right? Okay. So now we are moving one step closer. Now let's see whether this limit exists. Limit as x tends to 0 of f into g. Now this is interesting. You will find that the limit exists. Okay. Fine. So to check whether the limit exists or it doesn't, we will find the right and left hand limits separately, because both these functions are piecewise defined functions. Okay. So let's first see the existence of the right hand limit. Okay. Let's first see the existence of the right hand limit first. Okay. So limit as x tends to 0 plus f of x into g of x is equal to limit as x tends to 0 plus, for our choice of functions, box x plus 1 into fractional part of x. Now we know that for any integer, okay, rather for any real number which lies between 0 and 1, its fractional part tends to 0 as we go to 0 from right in this case. So clearly this function's limit is 0. Okay, and what is the limit of box of x plus 1 as x goes to 0 from right? Every number you will find that in box x plus 1, the x plus 1 part will be greater than 1, so its limit will be 1, right? This limit will be equal to 1. So using the algebra of limits, as both right hand limits exists, we can use that and get the result to be 0. Okay, so right hand limit is 0. Now let's talk about the left hand limit. Okay, let's now talk about the left hand limit. So limit as x tends to 0 from left, 0 minus f into g, our functions. Now you realize that the fractional part will actually tend to 1. Okay, the fractional part will now actually tend to 1, right? Because it is negative 1, then well, when it comes to negative 0.1, the fractional part is actually 0.9, you know that. Okay, so in the limiting case it will be equal to 1. Okay, and what about the limit of box x plus 1? The limit as you approach 0 from left, because every number there is negative, okay, that number when added to 1, that will still be less than 1 but greater than 0. So the greatest integer less than or equal to that particular number is 0, So this is also 0. Product of these two things is also equal to 0, and therefore both the limits exist. Both the limits means left and right of the function f into g at 0. So this basically proves that both the limits, none of the individual limits exists. Limit as x tends to 0 f and limit as x tends to g, they don't exist. Okay, we have already talked about that here. But the limit of the product exists, which rules out option D, which tells us that either this should be 0 or that should be 0. That is also something which is contradicted with what we had assumed. So it has to be option A, which tells us that the limit of f as x tends to 0 need not exist. It means it may exist, it may not exist, it is not going to affect the limit if that limit exists. Okay, now let's verify this graphically. I don't think you need any verification for sin x by x, so we will do it for the box x plus 1 and fractional part. Okay, we will use Desmos now. So f of x is the floor function, that is the greatest integer function. Okay, so you can see that the function's right limit and left limit, they are different. So the function has an irremovable discontinuity, hence the limit doesn't exist basically as x tends to 0. Okay, let's talk about the fractional part function. Even here the left limit is 1, right limit is 0. So that is also a non-limit existence question. Okay, so both these functions individually don't have a limit as x tends to 0. Now let's take their product. Okay, if you take their product, what you will find is, although these functions are discontinuous at many things, at many points, in particular at every integer, you see that 0 is the only exceptional case for them where the continuity requirement is met. The left limit is 0, the right limit is 0, and the value of the function is also 0 there. So for us the most important part is the existence of the limit, right? So because the limit exists, our answer is correct. Okay, let's go to 34. Let A be a 3 by 3 matrix and A prime its transpose. Suppose that the determinant of A into A prime is not equal to 0. Then the system of linear equations A into xyz equal to 1, 2, 3 has no solution, exactly 3 solutions, infinitely many solutions, and exactly 1 solution. Okay, now this is a standard problem in what we call linear algebra, whose main task, or one of the main tasks, is to solve the system of linear equations Ax equal to b. Okay, the other fundamental problem in linear algebra is the eigenvalue problem, which we will learn in the very next year. Okay, that is after your 12th. Alright, now as far as the question is concerned, it is based not much on the knowledge of matrices but the knowledge of determinants. Okay, now we know that the determinant of the product of two matrices of the same size, or basically square matrices, is actually equal to the product of the individual determinants. You know that. So if determinant of A into A prime is not equal to 0, it implies that determinant of A into determinant of A prime is not equal to 0. And we also know that the determinant of any matrix is also the determinant of its transpose. You know that, right? So if the product of two things is not 0, none of them should be 0. Okay, so this basically proves that A is non-singular. That means its determinant is not equal to 0, which means that the inverse of A exists. And the existence of the inverse implies that the system that is here, okay, let's call it Ax equal to b. So if I extend this now, if I pre-multiply both sides by A inverse, you will get x as A inverse into b. And because we know that matrix of inverse of any square matrix when exists is a unique matrix, it confirms that the vector x will also be a unit vector given by A inverse into b, thereby confirming that it is a problem whose correct option is exactly one solution. And we already know that solution, that is A inverse into b. Okay, now the things here 1, 2, 3, it's immaterial. Okay, whatever numbers you write here, it is still immaterial because of the existence of A inverse. No matter what numbers you write here, the system will still possess exactly one solution. Let me also tell you that Ax equal to b will never have exactly 3 solutions. So you could have eliminated this option right away. Okay, it will either possess unique solution, or it will possess infinitely many solutions due to the property of linearity, or it won't possess any solution at all. Okay, now this behavior is decided by what we call rank of a matrix, which is a number associated with not only square matrices but with also other every matrix has a unique rank. You will definitely talk about this or learn more about this in your later linear algebra or mathematics courses. Okay, but as far as 34 is concerned, I think it was a fairly easy problem. Question 35. Let L be a line in the plane X, in the xy plane, and P be a point not on L. Okay, so P is not on L. The set of points in the plane which are equidistant from P and L is, it's a very simple problem which is based on what we call the focus directrix property of conic sections. Okay, so to understand what this property is, let me use more standard notation. So suppose this is the line. Okay, let's call this line as L, and suppose S is that fixed point. Okay, S is the fixed point not on the line. Okay, this S basically becomes the focus of our conic. Okay, and this L is the directrix. Okay, this L is the directrix. Now in general we say that P is our variable point, so let me use that notation now. Okay, suppose point S is somewhere here. Sorry, point P is somewhere here. So this is our variable point. Okay, and so I'm not following the problem's notation now, but I'm following more standard notation available in the textbooks. Okay, so this is our variable point. Now P can be anywhere, but we only want to pick those points P, okay, such that the distance between the point and the fixed point S, okay, this point, this distance rather, SP, should be equal to the perpendicular distance of the point P from L. Okay, so suppose the foot of the perpendicular is M, so this decides the nature of the conic sections. Okay, the focus directrix property is this, SP equal to EPM. Okay, that is the focal distance of the point and the distance of the point from the line, which we call the directrix. This ratio decides whether it is ellipse, parabola, or hyperbola, or I mean in a limiting case, circle. Okay, so when the distances are equal according to them, SP equal to PM, eccentricity is 1, and that is there for parabola. So as far as the problem is concerned, you know the answer. The answer is parabola. Okay, if E is less than 1, then it is ellipse. If E is greater than 1, then it is hyperbola. Okay, I think this was the simplest problem of all as far as the calculation involved or concepts involved is concerned. But yes, in a way it is also conceptual, because no matter how much you know about the standard equations of all of them, general equations, then what happens if you rotate the ellipse, many things, but they don't want that. They just want you to know the focus directrix property as far as this problem is concerned. Okay, I've seen many students focusing more obviously on the numerical part of the conic sections or in general anything, but this is the basic. Focus directrix property is the basic property of all conic sections, so you should also know it. In addition to that, you should know the other things: y squared equal to 4x, x squared equal to 4by, then what happens if the parabola is inverted, other things, rectangular hyperbola, eccentricity of them, so many things, but this is the basic. Okay, we have solved it, simple. Question 35, answer is parabola. Let us now solve question number 36, which says the set of all real numbers alpha for which the polynomial, cubic polynomial, x cube minus 3x plus alpha has 3 distinct real roots is. Okay, the number containing 0, that means only one value alpha which is equal to 0, interval closed at 0, open at 3, interval open at negative 3, closed at 0, and the open interval negative 2 to positive 2. Okay, now first thing that you should understand is about this cubic polynomial is that because of its coefficient of x cube being positive, we know for sure that the limit of this function, let's call it f, as x tends to infinity is infinity, and the limit of this function as x tends to negative infinity is negative infinity. So if I visualize how the graph of this particular polynomial is going to look like, it should be something like this. Suppose the pink line is our x-axis. Okay, because of these limits that we have written here, we are almost sure, rather we are sure that as you go from left to right, the values of the function are in general found to be increasing. That means I'm talking about the fact that we won't be having a polynomial like this. Okay, it increases in this way and decreases. Okay, this is not what we are talking about. Okay, fine. So I hope you got the point. Because the limit of f as x tends to infinity is infinity, this is not right, because this is going downwards, negative infinity. We don't want that. Okay. Now we want the polynomial to have 3 distinct real roots, which also means that our graph should intersect the x-axis at 3 different points. Which also means that if these are the locations where the curve meets the x-axis, the roots or the zeros of the function, it should also have one local maximum at A and one local minimum at B. More importantly, the sign of the local maximum should be positive and the sign of the local minimum should be negative. And due to this particular arrangement, we can draw the following results. Result number 1, A should be less than B. Result number 2, f of A and f of B should have opposite signs, and one of them, well, f of A specifically should be positive, the other one will be negative. And the third thing is obviously where first derivative test, the sign of the value of the derivative of the function given at A and B should be 0. Okay, so we'll start with this. Suppose we take the function and obtain its derivative. X cube minus 3x plus alpha, derivative will be 3x squared minus 3, alpha's derivative 0. You equate the derivative to 0. If you solve, you will get two things, x equal to plus or minus 1. Okay, so we have not got the roots now. Please keep that in mind, because the roots will depend on alpha. What we have got is the values of A and B, which are negative 1 and positive 1 respectively. Okay. Now let's make use of the result number 2. F of A is positive, f of B is negative. So if f of A is positive, for us A is negative 1, right? Let me use blue color for that now. Okay, what will be f of A now? Okay, you substitute it in the definition, x cube minus 3x plus alpha. Cube of negative 1 is negative 1, 3 into x with a negative sign will be 3 plus alpha, so this will be 2 plus alpha. We want this to be greater than 0 because of the condition here. So that gives me that alpha should be greater than negative 2 all the time. Okay, simple inequality, 2 plus alpha greater than 0, so alpha should be greater than negative 2. Next, let me use pink color now for f of B thing. F of B is 1, so what is f of B now? F of 1, 1 minus 3 plus alpha, so negative 2 plus alpha, this should be negative, that's what we want. Okay, it should be negative, so which also means that alpha should be less than 2. If you take the intersection of these two intervals, it turns out to be this, negative 2 to positive 2. Okay, fine, so that's the correct answer. Now the other thing that you should know about this problem is that alpha is basically responsible for shifting the whole of this graph up and down. Okay, it is not going to change other behavior of the graph of the function. We'll see that on Desmos. Okay, so this is the function x cube minus 3x plus alpha. Let me just check it once again. X cube minus 3x plus alpha, yes, that's right. Okay, so this is the slider that I'm going to bring in now for alpha. Now you can see that currently at negative 1 we have that in our range from negative 2 to positive 2. Okay, x equal to negative 2 and x equal to positive 2. Okay, now you keep an eye on what happens to the curve as I slide. Okay, as I increase the value of alpha, you see that the graph is shifting up. Okay, and the moment it reaches 2, okay, we still have one root here, but the other root that you see here, okay, you can say it's a double root. Okay, it is a double root. That means the polynomial has only 2 distinct roots there. Okay, so that exactly is what happens when alpha is 2, and if I increase alpha, this graph will further go up and there will be only one real root, okay, which is outside, which is less than -2. Okay, you can see that here somewhere, well, closer to -2.064. Okay, now what happens if I slide this downwards, negative? Okay, if I start to take values of alpha smaller and smaller, you'll find that the graph shifts down, and now the thing that took place in the first quadrant, you'll find that thing happening in the second quadrant as well. The moment you take alpha to be -2, it is again a case of double root. That means only two distinct roots. One of them is 2 and the other one is -1, but we don't want this. That's the reason we are excluding the possibility of alpha being 2 or -2. Okay, and if we further decrease alpha, then there will be only one root which falls outside the range -2 to +2. So our answer is correct. Let's now go to question 37, which was another easy question from binomial theorem. The coefficient of x in the binomial expansion of 1 upon x raised to 1 upon 3 plus x raised to 1 upon 2 whole raised to 7 is 14, 7, 35, 21. You expect the coefficient to be a multiple of 7 because of 7 being the power, and all of them are, well, multiples of 7. It's a very simple question. You have to first recognize the general term here. Okay, general term in the binomial expansion, which is the r plus 1th term, is NCR into a raised to n minus r into b raised to r. Okay, so first term is a, so that is x raised to 1 upon 3. Okay, so this is in the expansion of a plus b raised to n. Okay, so a is x raised to 1 upon 3, -1 upon 3, because that is in the denominator. Okay, b is root x or x raised to 1 upon 2, and n is equal to 7. So the general term would be 7cr into x raised to -1 upon 3. So I have deliberately written that in the numerator. So -1 upon 3 into 7 minus r, because n is 7, into x raised to r upon 2, because, well, b itself is root x or x raised to 1 upon 2, and it is b raised to r. Okay, now they are saying coefficient of x. Okay, they are saying coefficient of x. That means x raised to 1. So the collective or effective power of x in that particular term should be 1, right? Okay, so what's the power of x now? Currently we have -7 upon 3 plus r by 3, okay, plus r by 2. This should be equal to 1, and that's exactly what we will do now, or we'll do next. Okay, -1 upon 3 into 7 minus r plus r upon 2 should be equal to 1. That is a simple linear equation in R. If you solve it, you'll get the value of R to be 4. Okay, well, let me explain that. So -7 by 3 plus r by 3 plus r by 2 equal to 1. R by 3 plus r by 2 is 5r by 6. Send -7 by 3 to the other side. It will become 10 upon 3. Then you do the calculation. It will be 60 upon 15, 5 into 3, so 4. Okay, so what is the coefficient now? Coefficient is 7cr. Note that the x raised to -1 upon 3 and x raised to 1 upon 2, they won't have any contribution to the constant term or the coefficient of any power of x, for that matter. Okay, in some cases that might also be the case, okay, but not in this case anymore. All right, so 7c4, 7 factorial upon 4 factorial into 3 factorial, 7 factorial upon 4 factorial is 5 into 6 into 7, 6 goes, so 35. Yeah, this option. Okay, 37 over. Let's go to 38, which is the only probability question, and according to me this is also fairly straightforward. In an urn there are 3 blue balls, 2 red balls and 5 green balls, all distinguishable from each other. Okay, what is the probability that the 2 balls drawn at random will have the same color? It's a very simple question. The probability that 2 balls drawn are of same color will be, in the denominator, the total number of combinations possible, 3, 2, 5. So when added you get 10. So in the denominator it is the total number of ways, so that's 10c2. Okay, now you want the balls to be of the same color, so they can either be 2 blue balls or 2 red balls or 2 green balls, right? So that's 3c2 plus 2c2 plus 5c2. 3c2 is 3, 2c2 is 1, 5c2 is 10, so it is 10 plus 3 plus 1, so 14 upon 45, so that is option D, or yeah, 14 upon 45. Okay, very simple. Let's go to question 39. I found this to be on a higher note in terms of difficulty level is concerned relative to other questions. Question 39. For any complex number alpha with imaginary part not equal to 0, okay, that means alpha cannot be a real number. Okay, which of the following statements is true? Option A. If alpha is a root of a quadratic polynomial with integer coefficients, then imaginary part of alpha is a rational number. Okay. Option B. The set of all the numbers a plus b alpha where a and b are real numbers is the set of all complex numbers. All complex numbers. Option C. Alpha is always a root of a quadratic polynomial with integer coefficients, and if mod of alpha is 1, then alpha raised to n is equal to 1 for some integer n greater than or equal to 1. I have two methods to prove to pick the correct option. One of them is the elimination. We will prove that options A, C and D are incorrect, so it has to be option B, and at the end we will go to option B and prove that that is only the right option. Okay. Alright, so let us start disproving A. If alpha is a root of a quadratic polynomial with integer coefficients, then imaginary part of alpha is a rational number. Okay, so we will now pick a quadratic polynomial with integer coefficients and we will find that imaginary part of alpha is not rational. That will disprove A. It's very simple. I have picked the quadratic equation x squared plus 2 equal to 0. Okay, note that it is a quadratic polynomial on the left, x squared plus 2 with integer coefficients, the coefficients being 1, 0 and 2. What are the roots? Simple. The roots are plus or minus root 2i, so alpha is that. But here imaginary part of alpha is not a rational number, it is an irrational number which is root 2 or negative root 2, so option A is gone. Okay. If it is a root of a quadratic polynomial with integer coefficients, then imaginary part of alpha has to be a rational number, no longer a rational number. Okay. Option C. Alpha is always a root of a quadratic polynomial with integer coefficients. Always a root, okay, with integer coefficients. Which means if we now pick a polynomial whose coefficients are not integers, and if we could find alpha, then with the given condition that imaginary part of alpha is not equal to 0, option C will automatically get eliminated. So this is what I have done. I have modified the quadratic equation that I used in option A, and this time I am going to take x squared plus 2 raised to 2 by 3, or you can say x squared plus cube root of 4, which is, you know, it is an irrational number, so forget about it being an integer. Okay, it is irrational. So what are the roots of this quadratic equation? The roots are cube root of 2i and negative of cube root of 2i. Okay, those are the roots. Now these two roots that you see here, these clearly satisfy the condition given in the problem that imaginary part of them is not 0. In fact, the real part is 0, the imaginary parts are basically plus or minus cube root of 2. What does it mean? It means alpha is not always a root of quadratic polynomial with integer coefficients. It can also be a root of a quadratic polynomial with non-integer coefficients. Okay, I mean, you might argue, oh, why not x squared, it is also 1. That's okay. One of them is an irrational number or is not a rational number or an integer. It disproves C. Okay, now let's go to D. Most of you might think that that might be the case due to Euler's formula, but we'll prove that it is not the case. Okay, if mod alpha is equal to 1, then alpha raised to n is equal to 1 for some integer n greater than or equal to 1. Okay, the converse is true. If alpha raised to n is equal to 1, then for some integer, then mod alpha has to be 1. Okay, let's disprove that. Okay, so we are given that mod alpha is 1. Okay, so because mod alpha is 1, we can say that alpha is cos theta plus I sin theta, excluding those values of theta for which imaginary part of alpha becomes 0. Okay, but that is going to matter very little to us. Okay, alright. Suppose I take theta to be root 3. Note that I'm not taking tan theta to be root 3. I'm deliberately taking theta to be root 3. Okay, just to note that root 3 is approximately 1.7 So which is greater than 1.57 or pi by 2 and less than pi. Okay. Now mod of e raised to I root 3 is also equal to 1. So alpha is e raised to I root 3 and alpha raised to n equal to 1 gives me, okay, so I've used Euler's formula here. Cos theta plus I sin theta is equal to e to the power I theta. Okay, so I've used that thing here. Okay, I mean theta being root 3. Okay, so alpha raised to n equal to 1 will give us e raised to I into root 3 into n equal to 1, and this is true only when root 3n becomes a multiple of an integral multiple of 2 pi. So it can be 0, 2 pi, 4 pi, 6 pi and so on, or the negatives of them, but that's not important. What's important is the values of n. The values of n are now 0, 2 pi by root 3, 4 pi by root 3, 6 pi by root 3 and so on. Okay. Now n's value given in the option D is some integer greater than or equal to 1, and none of them turns out to be the integer except 0. Well, 0 is an integer, but it is not greater than or equal to 1. So we now have a complex number here, e raised to I root 3, whose absolute value or whose modulus is equal to 1, but that number raised to any integer is never going to give us 1 except 0. Okay, so option D is wrong. So because A, C and D have gone, what remains is B. Okay, so B is the right option, but we will now also prove that it is the right one. How? Okay, so we basically want to show that for all value, if we pick all values of A and B, okay, and of course given alpha needs to be fixed, then no complex number is missed. Okay, so this is what we'll do to prove that B is right. Assume that alpha is of the form p plus iq. Okay, now as alpha is fixed, okay, because we are not putting any restriction on that, we want the set a plus b alpha to represent the set of complex numbers, all complex numbers for any value of alpha. Okay, so p and q get fixed with alpha. Okay, and also q not equal to 0. Q not equal to 0, we know that. Okay, so what is a plus alpha b now? A plus alpha b, separating the real and imaginary parts of this number, alpha is p plus iq, and they have already said that a and b are real. Right, they have already said that a and b are real numbers here. Okay, so separating the real and imaginary parts of a plus alpha b gives us a plus pb to be the real part and bq or qb to be the imaginary part. Now let's equate this with the general form of complex number, that is z equal to x plus iy. Okay, now let's focus on y, which is bq. Okay, let's focus on y, which is bq. We know that q can't be equal to 0. What does this mean? This basically means that for every real number b, okay, we are covering every value of y. Okay, what I mean by that is, if q is not equal to 0, if I go on substituting different real numbers here, for every real number there will be a unique real number associated, which will be y upon q, or if I have b, if I multiply it by q, I'll still get y equal to bq. Okay, so this is basically a linear function now. Okay, y equal to b into q, q is fixed, so as we change b, y will automatically change, and because range of any linear function is the set of real numbers, we have now covered every possibility of imaginary part of z. Okay, every possibility of imaginary part of z is covered because imaginary part of z is y. Okay, fine. So what we have now proved is that at least in this case we have covered the possibility of purely imaginary numbers and 0. Okay, that's what we have covered here by considering y equal to bq. Now let's go to real part. What is the real part? Real part is a plus pb. That is the real part. Okay, let's come to that now. Now again I'm going to consider two possibilities because there is no restriction on the real part. We'll consider two different possibilities, p equal to 0 and p not equal to 0. Suppose p is equal to 0. Okay, then it basically becomes the case of y equal to bq, x is equal to a. So for every real value of a, for every real a, x becomes equal to a, right? So this is very similar to y equal to bq. Every real number x you will get if you keep on changing the value of a, you'll get an identity function there. Okay, possibility 2, suppose p is not equal to 0. Okay, suppose p is now not equal to 0. So what can we now say? Suppose p is not equal to 0 but is a fixed thing. Okay, can we express x as a linear function of f, a and b? Yes. And the range of a linear function is always the set of real numbers, no matter how many independent variables are there. So this also means that the whole of the set of complex numbers is covered because every real number x is getting covered now. Okay, so we have now proved that no complex number is missed. For if you take any, it means if you take any complex number whose imaginary part is not equal to 0, and if you take a linear combination a plus b alpha, where a and b are real numbers, it covers the whole of the set of complex numbers. Alright, so that was question number 39. Question 40. The complement of the set of all real x's such that mod of x squared minus 1 is less than 3 in R is, and we have 4 options: negative infinity to negative root 3 minus 1 union root 3 minus 1 to infinity open intervals, negative infinity to negative 2 union 2 to infinity open interval, and then we have the same options with the closed interval here. Okay, fine. Now the very fact that they're asking us for a complement of this set whose solution set will definitely consist of open intervals, okay, its complement will be a closed interval kind of thing. So it has to be either this option here or this option. So we have to decide that. Okay. Well, there also is a shortcut to do that. You know what I mean. Okay, you have to just try substituting these values and pick the right one. Okay, which one of them satisfies? You have to pick the appropriate option there. Okay, fine. So well, we will obviously not be using the elimination method. We have used it enough. So in this paper, so let's do the actual method. Okay, simple. Okay, when you have mod of x squared minus 1 less than 3, it basically means that x squared minus 1 will lie between negative 3 and positive 3. Follow the rules, follow the rules of inequality, add 1 to both the sides, negative 3 becomes negative 2, 3 becomes 4. Okay, now there is no point in talking about values of x squared which are less than 0 because they want x to be real, right? So that's why I've added this thing here, so that negative 2 thing can be replaced by 0 now. Okay, so 0 less than x squared less than 4 means x is in between negative 2 and 2, so x belongs to negative 2 and 2 open interval, so its complement has to be this one. So that is the correct option. Okay, negative infinity to negative 2 union 2 to infinity closed interval at negative 2 and 2. Okay, now this is the graphical explanation to that. Okay, the green colored graph that you see is that of the function x squared minus 1. Okay, x squared minus 1, this is the graph, the green colored. Okay, what they want us to determine the complement of the set mod of x squared minus 1 less than 3. So basically they want us to determine the set mod of x squared minus 1 greater than or equal to 3. Okay, so this is the region that has been highlighted in the red color. Don't worry about the red thing, I just want you to focus on this. Okay, you notice that on the x-axis, if you are to the right of 2 or to the left of negative 2, okay, the value of the function is always greater than 3. The y equal to 3 line is this line. Okay, y equal to 3. So if you take any point, look at where its y coordinate is. Its y coordinate on the graph of the function will definitely be above 3, as you can see, because at negative 2 and positive 2 it's 3. Okay, so that confirms that our solution is indeed right. Alright, the other thing is this thing. Okay, because when x becomes equal to 1 or negative 1, the function becomes 0. if you had just plotted x squared minus 1, then it would have gone like this. Okay, but because we are taking mod, then that part has been mirrored. Okay, but anyways, the example was a fairly simple one to solve. Okay, question number 41, a problem on counting principles or combinatorics and linear algebra put together. The number of 4x4 skew-symmetric matrices with entries in the set -1, 0, 1 is 3 to the power 4, 10, 6, 3, 4 raised to 3, 4 cube. Okay. Now this is also a very simple problem. I didn't find anything challenging here. If you have the basic understanding of what a skew-symmetric matrix is, what is the definition of it, and the counting principles, the multiplication principle in particular, then you can very easily solve the problem. Okay. First thing to note that if you take any 4x4 matrix, okay, if you take any 4x4 matrix, then it will in all have 16 entries, 16 elements. Okay. But as far as skew-symmetric matrices are concerned, the very definition puts the restriction on the diagonal elements of them. Okay, diagonal elements are all 0. Okay, so out of 16, 4 are already gone. Okay, there is nothing to be determined there. 4 are gone, 4 are dependent. Okay, now let's go to the remaining 12. That is the elements which are non-diagonal elements. That means elements which are either above the diagonal or below the diagonal. So if 4 are gone, what remain are 12. So there will be 6 above the diagonal and 6 below the diagonal. But you also know that for any non-diagonal entry of a skew-symmetric matrix, we have this characteristic. Aij is equal to negative Agi or vice versa in usual notations. Which means if an element above the diagonal is fixed, say Aij, then automatically Aji gets fixed because Aji is basically negative of Aij, or Aij is the negative of Agi. So how many independent locations are we now getting to choose? There are only 6 of them. See, originally there were 16. We had to get rid of 4 of them because the diagonal elements were always 0. So we can't make a choice here. Okay. And then remaining were 12, but even out of 12, 6 were dependent on the other 6 because of the property of the skew-symmetric matrices. Which means how many independent locations are we getting? There are only 6 of them. 6 independent locations. At every location we have 3 choices, -1, 0 or 1. So overall there will be 3 raised to 6 or 729 skew-symmetric matrices that you can form with entries from the set -1, 0 and 1. So the correct option is 3 raised to 6, that is. Let's go to 42. It is a conic section problem. Let f be the focus of the parabola y squared equal to 2x, and let p and q be the points of intersection of the parabola and the circle x squared plus y squared minus 2x minus 2y equal to 0. Then the area of triangle PQF is 1, 1 by 2, 2, 1 by 4. It's a very simple problem. First of all, you have to understand that if we have a parabola y squared equal to 4ax, then its focus will be a comma 0. So if you compare y squared equal to 2x with y squared equal to 4ax, you will get 2 equal to 4a or a equal to 1 upon 2. Okay, so we have got one vertex of the triangle. Observation tells us that none of these equations has a constant term in it. So the other point, okay, is origin. Both the curves pass through origin. So that's the second point, but of intersection. And if you quickly visualize the circle and identify the center and the radius, then you can also guess what the third point. Well, I have not gone that way. I have actually solved the equations simultaneously. Okay. So first thing is that you go to the equation of the circle, okay, and the term y squared is there. You replace the term y squared by 2x because y squared equal to 2x for parabola. Okay. That immediately leads to the cancellation of plus 2x and minus 2x. And what you get is x squared minus 2y equal to 0 or x squared equal to 2y. Okay. Now if x squared is equal to 2y, then x raised to 4 must be 4y squared on squaring both the sides. Okay. Then what is y squared again? Y squared is again equal to x, isn't it? Y squared is again equal to x. Oh sorry, y squared is 2x, sorry. y squared is not equal to x, y squared is equal to 2x. Alright, so that makes it 8x. Now if you solve the cubic equation x raised to 4 equal to 8x, not the cubic equation, sorry, it's a biquadratic equation, x raised to 4 minus 8x equal to 0. Okay, if you take x common, then it will be x cube minus 8 equal to 0. So it will have two real roots, one being 0 and the other one is 2, and the other two will be the complex cube roots of 2. Complex cube roots of 8. But of course we are not interested in the complex cube roots, we are happy with 0 and 2. Okay, so we have got one coordinate, one point has x equal to 0 and y equal to 0, obviously, as I said earlier, origin, and the other point is x equal to 2 and y equal to 2. It's very simple. Y squared is equal to 2x. Get the y coordinate by substituting x as 2. So if x is 2, then y squared will be 4. So y will be plus 2 or minus 2. Well, it is safer to take the y coordinate to be 2, or to use the equation of the circle to actually calculate the y coordinate, okay, which is 2. Okay, alright. So the other point is 2, 2. And you can very easily see that 2, negative 2 does not lie on the circle. Okay, 2, negative 2 if I take, so 4 plus 4, this is 4, negative 2, so this makes it positive 4. So that doesn't lie on the circle. So that's confirmed now. Okay. So it's now easy to plot the points now, because 0, 0 is P, 2, 2 is Q, and the focus is 1 by 2, 0. Okay, so it's here, 1 by 2. P is the origin, Q is this point, half base into height, simple. Area of triangle PFQ. Base is 1 by 2, PF. Height is the y coordinate of Q, which is 2. So the area is 1 upon 2 square units. This area. Okay, 1 by 2 is there. So this is the right option. Done. Let's now solve question number 43. Let f of x be equal to sine cubed of rx, where r is a non-zero real number. Which of the following statements is true? A. If r is positive, then f is increasing on the open interval pi by 2r to pi by r. If r is negative, then f is decreasing on the interval negative pi by 2 mod r, comma 0, open interval. If r is negative, then f is decreasing on the interval, open interval, negative pi by mod r to negative pi by 2 mod r. And if r is positive, then f is decreasing on the open interval 0 to pi by 2r. Okay. The problem is very simple if you know two things. I'll tell you which two. First one is clearly the application of derivative, which is if the derivative is positive, the function increases. If the derivative is negative, the function decreases, strictly increases, decreases. And if the derivative is equal to 0, then the function is stationary, which is the boundary thing. Alright. So what we will do is we'll first find the derivative of the function sine cubed rx by chain rule, which will be 3 sine squared rx, derivative of the outermost function, into cos rx, derivative of the intermediate function, into r, the derivative of the innermost function. Okay. Now let's consider the terms which are never negative, 3 sine squared rx. So this is not what we will now look for. If we want to decide whether it is increasing or decreasing in the given intervals, it is this part that we'll consider, r cos rx, because that can be positive or negative or even be 0. Okay. So as 3 sine squared rx is always non-negative for all values of x and r, the behavior is governed by r into cos of rx, so that is what we will consider in our analysis. Okay, that is what we'll consider in our analysis. The other behavior that I want you to note is that, you might already know this, but let me explain it to you once again, we'll need it. Okay. And the behavior that I'm talking about trigonometric functions is that, okay, let's say you take cos rx. Okay, now many people would argue that if I increase r, then the graph will actually stretch, but that doesn't happen, the graph actually shrinks. Okay, so I will not need x equal to pi by 2 into r, okay, as the first intersection of my graph with the x-axis. to the right of y-axis, but it is actually x equal to pi by 2r that I'll need. Okay, look here, for r equal to 1 it doesn't matter, but the moment I go to other values of r not equal to 1, then you find that the first intersection takes place at pi by 2r, that's the blue line and not the other line. Okay, you can see that. Okay, you just keep an eye on where the graph intersects the x-axis first, to the right of y-axis. Okay, and same thing will be observed here. Okay, so it's pi by 2r instead of pi by 2 for cos x. Okay, so the graph actually shrinks if r is greater than 1. Okay, so coming back to this, the problem, the significance is these options that you see here, okay, as 1 upon r and other stuff. Everywhere you see pi by 2r, pi by r, or pi upon 2 mod r. Everywhere the reason you see r in the denominator is because of the fact that pi by 2 in cos x is equivalent to pi by 2 r in the denominator for cos rx. Okay, that's the whole point. Alright. Now we will eliminate the options, of course, and first of all we'll consider options A and D where r is positive. Okay, we'll consider these options where r is positive. Okay, so what do we know about cos? Okay, we know that, well, see, r is positive now. Okay, so whenever cos rx is positive, well, the function will increase. See, what do we know about cos theta or cos x? Cos x is positive when x belongs to the interval negative pi by 2 to positive pi by 2. We know that. Okay, this is basically what we know. Alright, so if I now change this x to rx, what can I say about cos rx being positive? It is negative pi by 2r and positive pi by 2r from what I showed you just now. Okay, which means if r is positive, then r into cos of rx will be positive when x belongs to this negative pi by 2r to positive pi by 2r, and r is positive, so whenever cos is negative, the function r into cos rx will be negative. So when will that happen? Okay, you know that cos of x, okay, you know that cos x is negative. We'll only consider the 90-degree part when x belongs to pi by 2 to pi. So if I make similar changes cos rx, then this will be pi by 2r and this will be pi by r. Okay, this basically leads to elimination of the options D and A. How? Let's read A. A says if r is positive, then f is increasing on the interval pi by 2r to pi by r. Okay, but here we are actually getting the result opposite to what we have for increasing functions. When x belongs to pi by 2r to pi by r, this interval, when x belongs to pi by 2r to pi by r, the derivative is negative. Right, so which means, see, derivative is negative. Derivative of which function? F prime is negative. So derivative is negative implies that the function should decrease. They have said that it is increasing, so A is gone. What about D? D says if r is positive, then f is decreasing on the interval 0 to pi by 2r. What we have got? What we have got is when x belongs to negative pi by 2r to positive pi by 2r, which automatically covers the smaller interval 0 to pi by 2r, the derivative is positive. The derivative is positive. What does it mean? It means that the function increases. They are saying function decreases. Wrong. Okay, so we have successfully eliminated the options A and D. Let's now decide whether it is B or C. Now we have r less than 0. So again I have taken a particular value. I have taken r to be negative 1 for simplicity. I mean, I could have also taken r to be equal to 1 for options A and D, but I wanted to tell you the shrinking and stretching kind of thing. Okay, so let's now decide whether it is B or C. Let's take r to be negative 1. Okay, suppose r is negative 1 for simplicity. Okay, we also know that cos of negative theta or cos of negative x is cos x. Yes, because cosine is an even function. So r cos rx will be negative 1 into cos of negative x will be negative cos x. Now, the intervals where cos x is positive, negative cos x will be negative. So in the fourth and the first quadrants, it will be negative. Okay, and in the third and the second, okay, negative pi to negative pi by 2, it will be positive. Okay, see, let me paste options B and C here for your clarity. Okay, these are the options B and C. Okay, let's first talk about C, which is the incorrect one. They're saying if R is negative, then f is decreasing on the interval negative pi by mod r and negative pi by 2 mod r. In our case, the interval is negative pi and negative pi by 2. What do we know? Is it increasing or decreasing? It is increasing because it's positive. Derivative is positive in that interval. They are saying it's decreasing, so C is not right. So it has to be B. If R is negative, then f is decreasing on the interval negative pi by 2 r to 0, which is automatically covered here. Negative pi by 2 to positive pi by 2 negative, so it is B. Okay, now let me also provide you the graphical explanation to this. Okay, let me also provide you the graphical explanation to this. Okay, f of x is equal to sine cube rx. We will first discuss the situations A and D. We'll keep R positive. You keep an eye on the intervals 0 to pi by 2r and pi by 2r to pi by r. Okay, fine. All right. So okay, so this is the graph, okay, of sine cube of rx. Okay, it's not sine of rx the whole cube. Okay, this is what I've plotted. Okay, the function raised to 3. All right. Okay, now I've currently chosen r to be 1.2, but I can take any value. Okay, you can see first of all, you notice the black and the red line. The black line is x equal to pi by 2r. The function is increasing there, and from pi by 2r to pi by r, the function is decreasing as long as r is positive. Okay, as long as r is positive, that behavior is maintained. Okay, so from 0 to pi by 2r, the function increases. From 0 to pi by 2r, the function increases, so it doesn't decrease. Okay, and the opposite behavior is observed for pi by 2r to pi by r. Okay, that means you look at the portion of the graph to the right of the black line and to the left of the red line. The graph falls down here in this interval. The graph is falling down, so the function decreases from pi by 2r to pi by r, doesn't increase. That's wrong. Okay, now let's focus on negative values of r. We need to consider the intervals negative pi by 2 mod r to 0 and negative pi by mod r to negative pi by 2 mod r. Okay, fine. So now let me hide these lines. Let me bring in these two lines. Okay, fine. So you need to consider the portion of the graph to the right of this line and to the left of y-axis. Okay, just focus on that. Okay, okay, let me also make r negative. Yeah, okay, fine. Let's go to option. Okay, what was the right one? B is right. Okay, let's go to C. C tells me that if r is negative, then f is decreasing on the interval negative pi by mod r to negative pi by 2 mod r. That means the graph should go down in those two colored lines, in between those two. No, the graph is going up. Okay, so that option is wrong. And the other one, f is decreasing on the interval negative pi by 2 mod r to 0. Yes, that's exactly what you see. The graph is falling down. The graph is falling down in this interval, and this behavior is observed for any negative value. Okay, any negative value, hence our answer is correct. Let's now solve question number 44, second last question in maths, which says, in the figure below, find the area of the shaded region enclosed by the curves y equal to x raised to 4, y equal to minus 1 into x raised to 4, x equal to y raised to 4, and x equal to minus 1 into y raised to 4. The curves are here. Okay, now although they form a very nice geometry, the procedure to determine the area bounded or the area shaded is very simple. Due to symmetry, the required area will be 4 times the area in the first quadrant, and that's exactly what we have done. Okay, this point here, it's 1 comma 1, goes without saying. By observation also you can find that, or by solving the equations simultaneously, the way we did it for circle and parabola problem. And this is origin. Okay, this is origin. Now this gives us the limits on the definite integral. Okay, first of all, let's look at the required area. Okay, required area, as in the required area in the first quadrant, it will be the area under the blue curve. Okay, what is the blue curve? X equal to y raised to 4. or y equal to 4th root of x minus, okay, so that's this one, okay, this blue area, minus the area under the red curve. What is the red curve? Area under the red curve is y equal to x raised to 4. Okay, so the white area is something that we don't want, so that's this. Okay, root x, 4th root of x is basically x raised to 1 by 4. Okay, x raised to 1 by 4, limits are 0 to 1, trivial, right, and 4 times that. Now integrate x raised to 1 upon 4, x raised to 5 by 4 upon 5 by 4, integrate x raised to 4, which will be x raised to 5 upon 5. Okay, then it will be 4 by 5 here and 1 by 5 there. For 0, it will be 0. So 4 minus 1, 3, 3 by 5 into 4, that is 12 by 5 square units. Yeah, okay, so whichever option reads 12 by 5, you will mark that option. Okay, another very easy problem, not challenging if you know the points of intersection of the curves. Okay, fine, so that's 44. The last question in the mathematics section was the only question from 3-dimensional coordinate geometry, and it was also an extremely straightforward, simple, formula-based problem. Question 45. The equation of the plane that is perpendicular to the vector 3i plus 2j minus 3k and passing through the point 3 to negative 3s, and we had 4 options. Now, if you know that if you have a vector which is perpendicular to the plane, okay, these become the direction ratios of the normal to the plane. Okay, and equation of a plane in its general form is ax plus by plus cz plus d equal to 0, you know that, where a, b, c are the direction ratios of the normal. So 3 to negative 3 should be the coefficients of x, y, z, or at least their multiples. And you find that that doesn't happen with this, and that also does not happen with this, right, 3 to negative 3. So it has to be either this or that. You could have checked it by substituting the coordinates of the point, which one of them contains this point, because these two represent parallel planes. Or alternately, you could take this forward and substitute the coordinates of the point 3 to negative 3 here. Okay, 3 to negative 3 lies on it, so 3 into 3 plus 2 into 2 plus negative 3 into negative 3 plus t equal to 0. 9 plus 4 is 13, 13 plus 9 is, oh sorry, 9 plus 4 is 13, yeah, okay, 13 plus 9 is 22. So d has to be equal to negative 22. So when you send it to the other side, it becomes 22. So it's this option. Okay, so we have now solved all 15 questions from the mathematics section of the IISER 2022 exam. If you have any doubt in any of these questions, or if you have any suggestions to make, either you can mail me or you can write your suggestions in the comments below. And soon I will be also uploading videos from the physics section, solved problems from physics. So stay tuned, and if you have still not yet subscribed to my channel, please do that. That helps me a lot. So thank you, and all the best for your IISER team.